Here's some examples of simple polynomial division. 6 of them straight out of a typical college algebra pre-calculus textbook. And the problem with synthetic division, and the reason why I don't like teaching synthetic division, is because it is so limited. If you take a look at these 6 pretty simple examples of polynomial division, synthetic division only works for the first 2. The last 4 cannot be done with synthetic division. And so synthetic division becomes a very limited tool. Yes, it's a very fast tool when it can be used, and it's a great shortcut. So if you can learn it quickly and easily, go for it. But I wouldn't waste a lot of time learning it. You'd be better off spending an hour trying to learn synthetic division, and instead take that hour and become better at long division, because long division works all the time for all questions everywhere. And so you're better off knowing how to do long division. So let's just do one side by side, a long and synthetic, and then we're going to do a bunch more long division so you can practice the better technique, right? Long division. All right, so we'll start with number 4, right? If we have to do the division, we set it up like we do any normal long division, right? If you were going to put a number into another number, you would do the same thing. Okay, and just like dividing by any number, you figure out, how many times it can go in. So you go to the first term, you go, okay, it's an x cubed, so x can go in there, 3x squared times. Now we do the multiplication just like we normally do. So 3x squared times this whole thing gives me 3x cubed, and then 3x squared times 4, right, gives me 12x squared. Then you subtract. So 9 minus 12 gives me negative 3x squared. And if I bring down the next piece, that's kind of what I'm working with now. I mean, technically the whole thing comes down, right? And now we're going x into this first term, and that goes negative 3x times. So negative 3x times x gives me negative 3x squared, right? Negative 3x times 4 gives me negative 12x. And then here is a tip that I like to tell my students. Rather than subtracting, it's better to change signs and then add, right? Because when you subtract a negative, you got to remember that you're adding. So up here, we could have taken this and we could have changed them to negatives and then added, right? 9 plus a negative 12, we still got a negative 3. And then here we realize that those cancel out and we get positive 12 minus 5. We're left with 7x, right? Then you can think about bringing down the one. You technically don't need to bring anything down, right? You're just working on, what's left. So we really only need to look at this first piece to figure out, and then same thing here. So to go into 7x, of course, we only have 7 more. So 7x and then plus 28, right? 7 times 4. Again, we can change signs, right? Make these negatives and then add. Those go away. And we're left with negative 1 plus negative 28 is negative 29. That's our remainder. All right, so when we do this division, we get this as our answer, right? 3x squared minus 3x plus 7 with a remainder of negative 29. If we were going to do this with synthetic division, we have to write in all of the coefficients of the polynomial, and if any of these were missing, like if it was 3x cubed plus 5x and this piece was gone, then we would have a 3 for the x cubed and a 0 for the x squared, right? But we have an x squared, we have 9 of them. And then we have negative 5 of the x's, and then of course negative 1 is our constant. Now, synthetic division can only be used when you have x minus a constant. And this is x plus 4. So in this case, c has to be negative 4, right? Because we have to write it as x minus negative 4. Now, all you do is bring down the first number, and then multiply, add, multiply, add, multiply, add. So negative 4 times 3 is negative 12. Add, which gives us negative 3. Multiply, which gives us 12. Add, which gives us 7. Multiply, which gives us negative 28. Add gives us negative 29. And you'll see that we have the same answer that we got in the circle, right? Because now when we put in the powers, this is 3x squared minus 3x plus 7. You're thinking, well, how did you know it started with x squared? Well, it always is 1 degree less than what I started with. I started with an x cubed, so now the answer is going to be x squared. So there's side by side of long division and synthetic division. Again, not a big fan of synthetic. You're better off spending some time with long division. Let's do a couple more examples of long division. All right, how about something as simple as number 6, right? That can't be done with synthetic division because of the 3 in front of the x. That's how limited synthetic division is. So instead, let's practice our long division. As always, we just ask ourselves, right, how many times can the first piece that we're dividing with go into the first piece of the thing we're dividing into, right? So 3x into 6x cubed can go 2x squared times. That gives me 6x squared minus 8x squared. We're subtracting, right? But it's the same thing as multiplying by a minus 1 and adding. Those go away. I have 9x squared. Bring down the 12x. Now again, 3x into this gives me plus 3x. So that's 9x squared minus 12x, right? Because 3 times 4 is negative 12. And this all goes away, right? And so because 3x can't go into 0, I don't have a constant term. I'm just left with this, and 5 is my remainder. So that's your answer. This, plus remainder of 5. And when we talk about a remainder of 5, we would normally write it so our answer would normally be 2x squared plus 3x plus 5 over, right, the thing we're dividing with. That's our remainder, right? 5 was our remainder, but when we write it as a fraction, it just becomes the next piece. All right, how about another one? Let's try the last one, number 8. The seemingly most complicated one that actually even has 3 pieces, and you'll see that long division works just fine. Okay, again, as always, you take the first term and figure out how it goes into the first term, right? So it's 2. Since we've got x squared, how many x's, right, do we have here? And if you remember the rules, there's 3 of them, right? Because x squared times x cubed, now you have 5 of them all together, you would have x to the 5th, right? So now do the multiplication. That gives you 2x to the 5th, and then 2x cubed times this gives me negative 6. Right, let me clean that up, sorry. Negative 6, right? 3 times 2, and then x to the 4th. And you go, wait a minute, I don't have an x to the 4th there, right? Well, common mistake. When you do long division, just like with synthetic division, you always have to have placeholders for any missing values of x. So you need to move all this stuff over and actually give yourself room for an x to the 4th. And now you've got room for that x to the 4th piece. And then, of course, we finish it with the third one, plus 2x cubed. Now, like I said, it's probably safer to change signs and add, right? So this becomes negative, this becomes positive, this becomes negative. And now we add them, those go away. 0 plus 6 is 6, right? 6x to the 4th. And then one of them, this becomes negative, right? So 1 minus 2 becomes minus 1, right? X cubed. No, you don't have to have the 1 there. I'm just, reminding us that it's 1 minus 2 because it's minus 1. All right. Bring down our next piece. So we have 3 of them to match up with these 3. And again, first term, right, into first term. So plus 6x squared. Do the multiplication. That's 18x cubed and 6x squared. Oops, this is a square. Again, change signs and add is probably the safest way. Once you get really good at this, you can skip this step and just subtract, but it's often safer to do it that way. So those go away. 18 minus 1 gives us 17x cubed. Negative 6, right? And a negative 2 because we're adding. Negative 8x squared. Bring down the 3x. One more time. Plus 17x makes 17x cubed. All right, 17 times 3 is 51 x squared, and then plus 17x. Change signs and add. Change, minus, right? So now when we add them together, 51 minus 8 becomes 43 x squared, and then negative 17, right? Plus 3 is negative 14x. Bring down the minus 5, and the last one, we've got plus 43, which gives me 43x squared. 43 times 3 is 129, so minus 129x, and then plus 43. Running out of room, so we're going to have to bring this up top, right? We're going to change signs and add, so negative, positive, negative. And then when we do the last addition, the squares go away, we get 129 minus 14. So our remainder right out here is going to be 115x, right? Because that's 129 minus 14. And then minus 43 plus a negative 5 gives me negative 48. And that's over our original thing, right? X squared minus 3x plus 1. So there's our answer right there. All right, guys. So I know it seems like long division is very difficult and long and tedious, but that's only because I'm explaining steps as I go, right? You can blaze through these pretty quickly, especially if you practice them. So practice your long division. That's the best way to